Welcome back to Air Quality Matters. We already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and coming up, a conversation with Rob McLeod, Professor of Building Physics and Sustainable Design at the Technical University of Graz, and editor of IMPAQS, a landmark study and report on ventilation and air quality in Austrian schools. IMPAQS, Improving Air Quality in Schools, investigated CO2 concentrations, ventilation rates, and indoor and outdoor environmental data in 1,200 Austrian classrooms spread over the 9 federal regions of Austria across the 2023 and 24 school year. The study also evaluated the benefits of installing CO2 monitors in classrooms as a means of improving ventilation practices and reducing the risk of airborne disease transmission. This substantial 300-odd page paper and accompanying summary report is a must-read for anyone looking into schools' air quality. We discuss the surprising and not so surprising findings, break down the impact of behaviour, agency and habits and how these affect outcomes, looked at the matched pair study of CO2 monitoring, which I thought was really interesting, and the indoor and outdoor air quality dilemma, and much, much more. Rob has a rich history in building performance, from Loughborough University through the BRE to Graz today, and brings a deep understanding of the subject of both this report and the context it sits in, not just in Austria, but internationally. I hope you really enjoy this conversation as much as I did, and a really important paper on a subject important to so many. Please don't forget to check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Rob McLeod. I suppose probably a good place to start, just to lead people in, is to give us just a little bit of an overall perspective on what this report is, IMPAQS, what that stands for, why it was commissioned, what was the idea behind it, because this isn't a small thing, is it? I mean, this was a substantive piece of work.
I've got a copy here. You can see it's there's a few pages in there, 300 odd plus. Yeah, that's just the English version, obviously. It's been a bit of work. It's fair to say I think the team, we're a fairly small team here. I work in the Institute of Building Physics, Services and Construction at the TU Graz in Austria. And how did this start? Well, it really came about in a very organic way and a very rapid evolution of things converging. And I think the key transition here was that I changed jobs. I was working in Loughborough as an associate professor, managing 2 EPSRC doctoral training centers, the Lolo CDT and the Urbi CDT, which had just launched. And in middle 2020, I was offered a position here in Graz. We were in a sort of lockdown at the time. So I moved to Austria during, I guess, the alpha wave of COVID. It was really crazy to arrive in a new country, in a new job, and be in a full lockdown or an intermittent lockdown. There were releases where we could go into work under strict conditions, but we were housebound basically for a lot of that time in this foreign country. It was kind of crazy. And I started thinking at that point, well, what can I do to help alleviate the situation? Because schools were closed. It was really chaos in the education system. The university had very strict rules. We had to reduce density in classes. We had to shift all of our teaching online for the first year. And I started thinking a lot about my skill set and what I could do to pitch in and try to make a difference in this situation. And I've had a kind of long-standing interest in ventilation and air quality, and I've done some previous research in that area whilst I was at Loughborough and also previously working for the Building Research Establishment. So I thought, let's go further in this field and see what can be done. And we started thinking about the situation in schools because a lot of them we knew, particularly in wintertime, were really poorly ventilated, if at all. And we thought that's got to be a factor in this. And around that time, there was a lot of research coming out of the States and elsewhere showing very clearly that the SARS-CoV-2 virus could be transmitted in an aerosolized form. So it was effectively airborne. And I think the WHO did a pretty good job of covering that up for quite a long time, or masking, or let's say downplaying the importance of that. But we started speaking with some colleagues at the Max Planck Institute in Mainz, Germany, because they were also starting to build ventilation systems. And they realized that we needed to get more air changes into rooms. And more importantly, we needed more effective ventilation air changes. So we then went out to Mainz, to Germany, and we looked at some of the schools out there, and they were building these kind of crazy mechanical extract ventilation systems on the fly, very cheaply, with these sort of umbrella hoods that sat above the desks with ducts leading out and joining into the extract fan. And we thought, brilliant, what a great idea. I mean, this costs a few €100 to build one of these systems. It was all done with material from the local building merchants. So we started doing that right away. We got students involved. Our first system was an absolute shambles of duct tape, buckets with flanges cut into them and sort of glue welded. But it worked. And we used our anemometer, we used our measurement devices, and we proved that it was effective, that this thing was working. And despite the fact there was no valves or common kind of building services kit involved, you could actually get a reasonably good extract flow through this. And it was consistent. You know, you were going from ad hoc ventilation to suddenly being able to put 1,000 cubic meters an hour through that room. And that was a game changer. We carried on doing that. At the same time, there was quite a lot of resistance. Some schools were very open to this, and others just thought this was crazy. You know, this was a step too far, that we were building these kind of strange ductwork systems.
And I remember, I think there were pictures floating around on Twitter at the time of these kind of the bits of, you know, white flexi tubing and bits of soil pipe and all sorts of buckets and all bits of tape. It was real Heath Robinson stuff. It was
absolutely
brilliant.
Heath Robinson. And it evolved from that. And we ended up getting a company in Frankfurt, Atmos Exchange, actually developed a commercial system that was a replica of that. It was sort of a sanitized commercial version. Honestly, I never liked it as much. I like the impromptu. I like the transparency of these kind of umbrella hoods. We still have some of the systems running. We've got one in our institute as a kind of, it's operational. It works perfectly well. It's in the reception area. We've got 4 hoods in there and an extract fan. It's running really quietly. It's doing its job. It's a great idea, but again, you need to get that further afield. It can't be just done in an ad hoc way like we were doing it in this very impromptu way at the time. It needs a wider rollout. It can't be, in Germany, they were building these systems voluntarily, using a lot of parents and teachers, but there was no mass mobilization. There was no government funding behind any of this. We had
I suppose one of the interesting things about that, Rob, is sorry to interrupt, is, you know, you saw a similar kind of resistance to the Causey Rosenthal boxes. Absolutely, as well. Yeah. And I suppose you can kind of understand it on a couple of fronts. One, at one level, large organizations are used to formal procurement processes, and it's very difficult to scale something if there isn't a standard behind something, or something that you can lean into that says it fits in these boxes for us to be able to do something at scale. But the other one, which I guess is more important, is the more Heath Robinson it gets and the more kind of open source amateur pull something together, it really does highlight a deficit somehow, doesn't it? That what you're in a way, what you're doing is you're putting a red flag up that says what we have here isn't sufficient, and look at what we've had to cobble together to make it sufficient.
Yeah.
You know, as an institution or an organization,
Yeah.
like that doesn't go down very well at the we know what we're doing kind of approach.
Certainly struggled with some of the facility management team. I mean, we were lucky we had support from our rector, so we had support from right from the top of this university, and the rectorate provided us with the initial funding to sort of pilot this. But when you got down to who's managing the building and who are we leasing the building from, and so on and so on, that's when we started to run into issues. And you also, unfortunately, it kind of shakes the marbles in the drawer a bit for commercial ventilation companies, and some of them thought we were trying to steal their business. And I mean, I've got a full-time job to do. The last thing I need to do is create a ventilation company and start running around schools and managing installations, which is what I was doing for much of 2022, even into early 23. But yeah, that's kind of a preamble to how I became immediately involved in this need to do something practical. And I think at the end of that, around the end of 2022, around that time, we actually invited the former Minister of Education, Science and Research, Professor Martin Poschek, to come down from Vienna and have a look at this and see what he thought about it. Because at that point, we thought, this is not going away. We need to do something. We need to scale up here. And he came down and was actually quite... it was almost like an awakening for him to see that you could do something, and the solution didn't actually have to be that complicated. And we talked to him about Corsi-Rosenthal box filters. We talked to him about the Max Planck NEV system. And we also pitched to him this idea that we needed to actually understand better what was going on across the whole of Austria in terms of ventilation, and what was the actual, what's ground zero, what was happening out there, because nobody knew. And the studies that had taken place had only sampled maybe up to a maximum of 20 classrooms. And you cannot get a good snapshot of an entire country by casting your hat around Vienna or some other place and just sampling a small number of classrooms. It's not.
And isn't that the way? I had Kath Noakes on the podcast nearly a year ago, I suppose, at this stage now, and maybe even longer. And that was the point that she made, that COVID was, on one hand, asking us questions about what the solutions were, but actually what we found out is that we didn't have a clue how any of our buildings were actually performing. So we were facing into ultimately this, well, where are we? Like, if we're going to have a solution, the first thing you need to understand in any kind of risk mitigation process is understanding where you are now, like what you're facing into. And I think I guess that's the start of that project, was that, well, hang on a minute, we actually haven't got a notion how our classrooms are performing.
Knew. I mean, we had a little bit of data. We had some other European studies, but context, as we subsequently found out, is all important in this. And there is no one school type. There's a huge variance, actually, both between schools and even within schools, from one classroom to another. So we needed to understand not just what's the mean situation, not just what's the average situation, But how does that variance, how does that distribution across the range look? In other words, what are the worst performing classrooms looking like, and what do the best performing classrooms look like, and what does everything in between look like? And not only that, what does it look like in summertime, and then what does it look like during the colder months? Because those are quite different situations. And so whilst you might get an average number that could actually on paper look okay, that hides a whole bunch of nuance. It's actually really, really important in terms of health inequalities across the whole school system.
That's really interesting.
That was another thing we wanted to look to. And then as part of this study, we had a series of aims. So benchmarking the current situation was clearly the main point, but we also wanted to trial out CO2 sensors to find out, because no one was using CO2 sensors in classrooms in Austria. Well, very few people were back at that time. And we wanted to know, do these things actually make any difference? And if they do make a difference, where do they make a difference? But not only that, there's a social side to this. What are the barriers and what are the drivers to using this? And how do classroom teachers deal with the CO2 sensor? How do they interact with them? And do they actually welcome them? Do they see a benefit from using them or not? So there's the actual quantitative stuff. So, all the measurement stuff, does it actually make a difference? But then there's all the qualitative stuff, all the human stuff about, will people actually adapt to new technology? Because there's always that technological adaptation phase that people need to get through and get beyond in order to get the benefit out of some new device or other.
And you mentioned something really interesting there about the need for scale and to understand the nuance, because you're absolutely right. In a lot of scientific endeavors, what we're trying to boil it down to is a p-value or a mean or an average or something that's statistically significant, so we can say something about something, right? And I get that completely. But in the world of engineering solutions and trying to solve a problem, that's limited in its helpfulness, because you need to understand that spectrum because you need to, particularly in a world of limited resources where we know we just can't fix everything all at once, we need to know how that bandwidth stacks so that we can direct resources at the places that need it most, and not forget, but park places that maybe are operating close enough to where we want them to be. And if you don't understand that bandwidth very well, you're not solving the problem. You're producing a paper that says this is the number that we can associate with X, but it doesn't solve the problem, does it?
Exactly. And that's the thing, that you've got to have a big enough data set, and you've got to make sure that sample is representative or sufficiently representative of the schools that you're trying to interact with. And we were very, very careful in generating our sample. We needed to get the sample size. So we needed the 1,200 schools to get the statistical power to make inferences at the 95th percentile statistically. But we also needed to make sure we sampled from the 9 Bundes regions, so the 9 federal regions of Austria, equally based on existing student numbers in those regions, so that we didn't oversample from one region or another. So you're making this stacked Monte Carlo sample from a whole bunch of factors, including the school type, how many of those types of schools exist, the age groups, the region, and all of that goes into building a good sample. So before you even get going, this is the kind of stuff you need to do. And we worked with the Institute for Quality Assurance in schools in generating the sample, because they had experience from previous research studies of doing that. So the IQS in Austria, whenever there's a research study involving schools, they get involved to help make sure you get the maximum benefit from that sample, and that sample is optimal in relation to the research questions and themes that you were trying to uncover. And I think that's critical.
Well, if anybody from SEAI is listening from the RD&D call that's out at the moment, looking at, I think there's some stuff out on ventilation at the moment. I was having literally just this conversation in the last couple of weeks that what we don't need is another Mickey Mouse study that looks at 50 buildings and just can't infer, there's no, you can't do building pathology at that scale. You need scale to, and if you want to do something meaningful at a big level, it requires investment and scale to do it. There's no shortcuts, because what you end up with is yet another report that says, well, we found these poor outcomes, but we can't really say why, because we only had 3 of those and 6 of those and 4 of those. And you're just going, oh God, again, really interesting.
You wish often they'd all team up and kind of do something at scale. And it's so important if you want to give evidence that's unequivocal, that can't really be refuted mathematically, statistically. You have to go through that process, and you have to work at scale, and therefore you need support to do this. You need substantial funding to do this. And I also think it's important to look longitudinally as well, and that's why we monitored over an entire year. We just didn't monitor for 2 weeks or 2 months. We wanted to see what happens over the entire school year, what happens in summertime when the going's fairly easy, when it's fairly tolerable to throw the window wide open, and what happens in the depths of winter. So we really wanted to...
So what's the elevator description then of this project? When somebody says, Rob, so what was the IMPAQS study? Describe the scale and what its composition actually was. What was the actual report itself?
The IMPAQS study, we call it the IMPAQS study. It stands for Improving Air Quality in Schools, and the main aim was to measure carbon dioxide, temperature, relative humidity in 1,200 classrooms across the 9 federal states of Austria. It took place over an entire school year, so the entire 2023 to 24 school year. It was a socio-technical study, so we also ran 4 surveys. We surveyed the school directors or head teachers before the study and at the end of the study to see if their attitudes and their knowledge about ventilation had shifted in that time. We also surveyed every classroom teacher, or issued the survey to every classroom teacher. So that's 1,200 teachers across the winter season and across the summer season to get their seasonal perspectives on ventilation and the challenges that they were facing at different times of the year. It's also a matched pair study, and that means we had 600 test rooms where we had a CO2 sensor that looks pretty much like this one here, and that had a visible display. And then we had the identical sensor with the display turned off on another 600 rooms. So we were measuring the CO2 at 2-minute intervals in both rooms, and those rooms were paired. Those rooms were as close to identical in each school as we could get them. That means they were on the same floor level, same orientation, same volume, same number of windows, same age group, as near as we could, with a little variance to make the numbers fit occasionally, but they're near to matched pairs. And that means that you could split that sample in 2 and you would have 2 identical pairs of data. We even randomized the room selection. So we knew the schools that were going to take part from our Monte Carlo sampling. And then when we got to the school, we created a random room generator tool to tell us that sensor goes in a test room and that sensor goes in a control room. So we'd set up what rooms could be paired, but we didn't know which one was the T test room and which was the C room until we actually arrived on site. And that's the kind of rigor that we put ourselves to ensure that we did not bias that data and, for example, choose rooms that we thought might give a better result for the test rooms and other rooms for the control rooms. So it's a match paired study. We also measured at the site of the school outdoors. We measured again the CO2 temperature, relative humidity, and also the air pressure, because those parameters are also influential in terms of the CO2 concentration. And that allowed us to normalize those values across all the schools. We calibrated the sensors for altitude. We tested them to make sure that they were giving readings within an acceptable range. And we went back into random samples of classrooms throughout the monitored year with a very, very high quality research grade CO2 sensor and checked the values in the room and recorded them and made sure that the sensors were reading within an acceptable degree of accuracy of a known calibrated value. So we had multiple calibration processes. We had ongoing quality assurance going out randomly to audit schools in process and check on sensors. We also had an entire cloud database. So we looked at that data. We had alarms set up, automated alarms to tell us if values had gone really high or gone really low, to alert us in case there was an issue that we needed to tend to. Most of the time, interestingly, the alarms went off because some kid blew into the sensor for a short moment and sent it up above 8,000 ppm or something like that. And so we could see that in real time in our data. You just get this classic spike shooting up, and you're going to have to clean that out of the final data set. So most of
some kids arsing around with the sensor. Yeah,
absolutely.
You can't take kids out the equation, can you?
No, absolutely. And it's fantastic that they interacted with it more than we thought, actually. So credit to them for taking an interest. And I've been in numerous classes doing this with colleagues, and they're taking these measurements to validate the sensor that's on their wall, and the kids are like, well, what's that for? What are you doing? And and they said, well, the light's now flashing amber, and it's going to flash red. And then the kids putting their hand up and saying, miss, we need to open the window. This guy here says that red's not good. And this is young kids actually getting really interested in this topic. And really getting it. And often, sometimes in winter, the teacher would say, well, I'm not opening the window, it's too cold. And the kids would say, no, we need to open the window. That's what the sensor says, And so it
shows the value of the paired study, I suppose, because like if you didn't have that, you would be able to have that baseline of what happens when people aren't reacting to something in the room.
And that's kind of what we wanted to see. Does it make a difference? And we were thinking, yeah, it just makes a difference maybe in a practical sense. It's kind of like driving a car, right? You're going along and it says the speed limit is, let's say here it would be 130 kilometers an hour on the Austrian motorway. And then if you don't have a speedometer, you could take a guess at that. Or, I guess with cars, you could try and do what everyone else is doing. But, the way people drive around here, that's no guarantee you're going to be anywhere within the limit. So, you're really shooting blind. And a lot of people, also in our surveys, they said, look, I don't need the sensor. I can walk into a room and I can tell you when it's stuffy. I can tell you when you need to open a window. And I think, that's great. It's good that people are using the sensors. But on the other hand, CO2 is odorless. And so are a lot of other, noxious chemicals and so forth. And also we become accustomed to them. So if you're sat in that room and you're not doing anything, after a while you become conditioned to that. And you may not realize that the concentration of pollutants is just rising ever upwards.
How big a team was it that involved in this, Rob?
It was, at the height of it, we had about 20 technicians during the installation phase working in parallel in kind of teams, but often individually once they were trained. There was myself as PI, colleague Professor Christina Hopfer as co-I on the project, and a small group of PhDs and RAs. And Yeah, and a statistician colleague from the Department of Statistics here. So the core team is the authorship on the paper, so we're talking, half a dozen people. But we had a huge amount of support from our technicians during the rollout to get everything installed on time.
I was going to ask that. Did you or your team personally place each of the sensors, because the scale is quite big here? So one of my questions was about the quality of the data that you were getting back because of placement and location, but also then the contextual information about those spaces, what ventilation system it has, what size the room was, how many occupants it was like. I imagine there was some really valuable information if you were on site that you were gathering that you wouldn't get if you were just posting these sensors out to teachers.
Yeah, no, absolutely not. No, we couldn't leave anything to chance in that way at this scale. So we ran dedicated training courses for the technicians. We showed them and gave them support guidance on the height that the sensor should be installed. So in the sitting breathing zone at about 1.2 meters above the ground. We taught them to keep them away from openable windows and doors, to use internal walls, also somewhere where the teacher could see the device. But then you've also got the challenge that you've got LoRaWAN radio frequency signal that has to go out from that sensor to a gateway, and the quality of that signal becomes really important. And whilst LoRaWAN is a great platform, and there's increasing numbers of LoRaWAN networks around, we had to create our own LoRaWAN networks in each school in order to be independent and not use their Wi-Fi systems or piggyback on other systems, because we needed to have the data secure, and we needed to make sure we could track that data all the way through the process. So,
and you captured them when you were deploying these room dimensions and characteristics and so on. So you had some contextual information.
Yeah, absolutely. We've got a massive, we created a massive database of survey information, and we've summarized some of that in the report, but it's quite extensive. We developed our own Zoho tool. So we developed our own kind of input tool for the technicians to use. And that was, modified Zoho form system with a lot of different parameters: room volume, orientation, heating system, glazing type, window opening areas, mechanical gearing, presence of air filtration systems or not, mechanical systems or not, a whole bunch of stuff.
Really interesting.
Yeah.
Describe for listeners then the typical Austrian school, or the fact that it isn't typical and that there's a range of history, because it'd be interesting from a context perspective. Everybody's mind's eye is immediately making up what an Austrian school looks like. So perhaps describe people the kind of, in rough terms, the kind of spectrum of buildings and ages that you found yourself going into.
Okay, yeah. So there's an enormous range of building types for schools in Austria, from very old, quite small rural schools, which might have, 10 classrooms or 12 classrooms in the whole school. There's even smaller schools, which we didn't include in the study because we needed to get a minimum size to make it economical to do this. Often some of the older schools have high ceilings, which is quite nice. And sometimes they have high level opening lights, or double window systems, maybe a sash window and then an upper window or two casements, which means that they can actually ventilate quite nicely in some of these old buildings. And some of them are actually quite spacious. They're really quite pleasant places to be in. Also thermally kind of massive structures. One of the local schools even has a chapel in it. It's a private school, and it's really quite a pleasant place to stroll around. On the other end of the spectrum, you've got a lot of modern schools, which are typically reinforced concrete construction, a lot of glass, which actually makes it quite difficult, especially when they've got low emissivity glazing coatings. That's quite hard to get radio frequency signals through. and you get real challenges then, and may have to use extra gateways to get the signal out of the school. Those schools can often have an inner courtyard, which is quite nice in terms of that at least some of the classrooms are away from busy roads and open out onto a play area or a sport area. So there's this huge range. Also, let's talk about ventilation systems. I mean, out of 120 schools, only 11 had a mechanical ventilation system. So that's, you're talking about 10% plus minus of schools. So the majority are naturally ventilated. And that's fairly typical. I was in Italy at a conference a couple of weeks ago, talking to colleagues down there. And that's also quite common in Italy and many other European countries, that a lot of schools, whilst your commercial buildings probably have mechanical ventilation, your modern commercial buildings, many of the school buildings don't. They're naturally ventilated. And we could get into that. I mean, you start talking about different window types. Are the windows even openable? That's there's a significant percentage of schools where you literally cannot open a window.
What was the school age group? I don't mean historically of the buildings, but was it secondary schools, kind of 10 to 18-year-olds? Was it primary? What was the bandwidth you were looking at?
Through to end of secondary. We didn't want the little kids that are still crawling around on the floor. Obviously, that's really problematic. You're going to think a lot differently about measuring in that space. But it's the Volksschule, sort of primary schools all the way through to the general secondary schools. And there's a lot of more career focused schools that do a lot of training. Some of those schools we had to leave out because their schedules are such that the students aren't there during the day. They're out on placements and so forth. So it wouldn't really give a like for like study sample. But wherever we could, we included all the school types through that age range.
Well, it sounds like really good bandwidth, really impressive scale. So I suppose we should talk about the report and the outcomes. You spent a year looking at these schools. You got a lot of data back.
Yeah.
And to everyone's surprise, all the schools were brilliantly ventilated. Nothing to see here, move along.
Yeah.
Next.
You wish. And it would be nice to report that it'd been all a complete waste of time, but at least reassured. But unfortunately, what we did find indicates a widespread failure of Austrian schools to comply with all existing European, international, and Austrian standards. And we say that because at least a quarter of the schools fail to maintain CO2 concentrations below the 1,000 ppm. And for 25% of the running time, we're seeing data that shows that they're ventilating below the absolute minimum requirement in the European norms. So below 4 liters a second a person. For a quarter of the operational time. And that is a massive failure. It doesn't mean every school failed, but it means that there's a big chunk of schools, a large swathe of classrooms where the children are not getting the bare minimum of fresh air into the classrooms. So either we need to do something about that. We need to think, what does that mean? And on the other hand, no classroom in any of the schools maintained below the 1,000 ppm on every single day of the study on average. So there's not a single classroom that met that target on every single day. And when we talk about these numbers, these are the numbers that are in the existing standards. We're not talking about any health-based standards. We're not talking about recent developments post-COVID towards the 800 ppm or higher ventilation rates that were proposed, for example, by the Lancet COVID Commission or in the ASHRAE 241 standard. We're not talking about that. We're just talking about existing norms and standards.
And where do they sit? Where do they sit in Austria compared to others? So typically, because I know it's a bit of a broad church, but generally speaking, we're somewhere in the 5 to 6 air changes per hour, 6 to 7 litres per second. Like BB 101 in the UK, for example, mechanical systems would need to be below 1,000 parts per million. You'd need 1,500 parts per million naturally ventilated schools.
Yeah.
There are models that have been used broadly for naturally ventilated spaces that would, you'd use to calculate with high and low opening windows that you would keep below certain CO2 level. So Austria isn't unusual in that there are some standards that would fit broadly with a lot of other standards for ventilation, would you say?
Again, if you talk about the average concentration, so the mean ventilation rate is actually reasonably good. It's 7.4 liters a second per person. If you talk about the median, which I prefer to talk about, it's 5.9 liters a second. So the middle value is 5.9 liters a second a person. So that's just slightly under ASHRAE 62.1, for example. And the mean, is not bad. But you've got to remember here that this distribution is skewed to the right by the fact we've got a few very well ventilated schools pulling the mean value up. So a lot of standards talk about the mean value, but forget that these distributions can and are often quite skewed. And you might be better reporting the median value, but for the average listener, we're probably splitting hairs. In reality, it's making quite a lot of difference around how you interpret that data. But just ignoring that for a minute, if we say that, these mean and median values are kind of okay, the problem is that half the values will be worse than that and half will be better than that. And the big thing here that I'm concerned about is we're not at the category 1 level. So we're not getting to the 10 liters a second per person. We're not getting below the 1,000 ppm on average. And even if we were on average, we'd still have some winners and losers in that equation. So we're quite a way below that. We're more than 40% below those target values.
Yeah, that's a really interesting point you make. And again, it goes back to this statistical value that we see in academic reports and things that say, well, look, this is the number. It's only 10% worse than we would expect it to be or whatever. And you're going, okay, fine. But actually that means then that, as you say, 30-40% of classrooms are below where they should be. Do we think that's acceptable?
Yeah.
And if we don't, what's the fix here? What does that, what is an acceptable value? And do we actually want those means lower? So that we've only got 10 or 20% of classrooms below where we want them to be.
It comes down to, okay, what's the mean value, but what's the variance? What's the interquartile range between, let's say, the lower quartile and the third quartile? So what's 50% of that data doing? And that's why we need to look at, I know statistics bug a lot of people, but they're actually really important to get your head around, because if you don't understand whether that distribution is very narrow or very wide, you're not really able to articulate or understand what's going on across the whole bandwidth. And what concerns me less is the mean value, but what's happening with the lower quartile? What is the 25th percentile doing? Because then you've got a quarter of your operational time down there, or a quarter of your schools down there. And that's the problem. If quarter of that data set fails to achieve the bare minimum, you're off the chart. You're not even in category 3 of the European norm of the EN 16798 part 1. You're below that, and that room is not fit for occupancy according to that standard.
Yeah.
And yet,
So we've just mentioned statistics and European norms in the same paragraph. So we've just lost 25% of the listeners.
I
So
know.
I promise. Yeah, we're thin
Yeah,
ice.
yeah.
But it's a very important point. Very
Yeah,
important point you
I'll
make.
try and stay away from those hard details. But in round terms, there's a huge lottery here that some kids are turning up and drawing the short straw. And
Yeah.
what it comes down to, I'll put it differently. If you look at the 10 best schools and the 10 worst schools, you've got on average 1,000 ppm difference from one group to the other. So if the average is at 1,000, some of them are performing somewhat better than that, but a lot of them are up above the 1,500, up in the 1,800 range on average. So that's their middle point. And that's the kicker, because if you're a kid and you draw the short straw and end up in the bottom 10 percentile in one of those rooms, then your education's impaired, your risk of getting infection has gone up, and so on and so on. The same applies to the teaching staff as well. You know, they've got rules, there's laws here about mechanical ventilation flow rates, and even some of the mechanically ventilated schools are not run in accordance with those regulations. But the thing is, who's checking? Who's checking on that?
Is Austria schooling system fairly unionized, like a lot of countries? Is it? Yeah, I've always been surprised that the teaching unions haven't picked up more on this. I mean, because at the end of the day, schools are workplaces too, and you know that they're a very organized bunch, teaching unions. And if I was a teacher and I knew that quarter of the a quarter of my workplaces I'm likely to be going into presents a risk, an unnecessary one potentially, that would be an issue for me. I would have thought.
It is, and they're quite active. We've presented to the union representatives of the Bundesregion, of the federal states, and some of them are very engaged about this. And it's actually going to be down to them to take this back to the Ministry of Education and say, hey, now we need to sit down. Now this report's out, we need to have a conversation about this, because this is not good enough. And it's jeopardizing their health. It's jeopardizing the learning outcomes of the students in their school. There's enough reports out to say that. And ultimately, you know, why provide suboptimal working conditions for the students, but also for the staff? And this pandemic has had a big impact on teachers. It's had a big impact on students. You know, we're seeing reports out of the States now about long COVID in American school children. There's sort of hidden epidemic of this. Damage is ongoing. And, you know, it's not just about COVID. It's about respiratory illnesses every year, every winter season. You know, it's time off work. And I just think,
and as the Safer Air Project points out, Plumstone and her work, there's also an accessibility rights issue. That, you know, there are children who are struggling to access education because of vulnerabilities, either with themselves or with family members, and these schools present a very real risk.
That's
an unnecessary
absolutely
one.
True, and you can quantify that risk as well, which we've attempted to do in the report. By modeling infectious aerosol dispersion in the space and looking at exposure times and what the risks are. And, you know, you can look at this different ways, but there is a very significant impact. Something like if you double the ventilation rate, you will reduce the risk by about 20% of getting an airborne infection. Okay, so you can't eliminate the risk, but it's influential. And I think that's important, because prevention for vulnerable people is going to be not about one single thing. It's going to be about layers of protections that we've been all talking about. It's going to be about allowing those vulnerable people to mask. It's going to be about keeping the air quality as good as you can within the classroom and consistently so that the combined risks are reduced, And there's other strategies that could go in there as well. There's filtration, there's upper room UVC. There's lots of ways to get infection risks down. So we don't need to just rely on ventilation to do all the heavy lifting here. There's many more strings in the bow that we could be drawing on. But ventilation is part of that picture. It's certainly part of that picture.
I'll have you back to the podcast in just a minute. I just wanted to briefly tell you about Eurovent Certified Performance from Eurovent Certification, a partner of the podcast. We all know HVAC systems play a vital role in improving indoor air quality. However, there is a risk that some products may not live up to expectations. Even the best installed and maintained HVAC equipment can underperform if data used to specify products and design systems is incorrect. Consequences can include poor indoor air quality, increased energy consumption, increased maintenance, system failure, and non-compliance with regulations. And that's bad for everyone. However, there is a way to ensure products perform as advertised and deliver good sustainable indoor environments. Selecting products holding Eurovent certified performance ensures that the manufacturer data has been independently and impartially verified. Eurovent certification's stringent certification process not only guarantees product performance, but energy efficiency too. I met some of the Eurovent certification team back in January at the Indoor Air Quality Matters conference and was seriously impressed with what they're trying to do. Their core aim is to create transparency in the industry by making certified data freely available. This means you can directly compare the performance of products to make informed decisions. Their certified product directory holds vital information on everything from air handling units to air filters. So don't take a chance on unverified products. Trust in proven performance. Details, as always, in the show notes at airqualitymatters.net and at Eurovent Certification. That's www.eurovent-certification.com. Now, back to the podcast. Yeah, and the risk is that we see doubling of ventilation rates as a law of diminishing returns, which it technically is, of course, and I do understand that, but we also have to go back to what you were saying in the previous segment about the fact that there is a percentage of schools that are ventilating very poorly. So actually often doubling those ventilation rates in those spaces, you're having a profoundly bigger impact on the risk in a lot of those. So we tend, when we talk about increasing ventilation rates, I think instinctively we think about the average or the mean of the spaces and go, well, what's the cost of doing something like that across the board? But it isn't necessarily about that. Sometimes it's about identifying the spaces that are underperforming and improving those significantly and being able to quantify the impact of doing that.
You're going to have the biggest impact bringing the worst spaces up to the middle than you are trying to go further with diminishing returns on schools that are performing well. I'm less worried about schools that can maintain hourly mean values below the 1,000. If they can get them down to 800, then great. If they've got good mechanical systems, that's attainable. But I would much rather see we bring down the concentrations in that lower quartile, in the worst affected schools, and we focus first on improving the ventilation there. And that's where this study gives value, because by cutting through the data, you expose those facts, and you can see very well that certain interventions work. CO2 sensors work. In the worst cases, they work well. They work particularly well in wintertime, and other things work as well. And so it's by bringing these things together, we can systematically, I think what we need to do is triage the schools and go through, get the data, and target the worst affected ones first. I really think that's the only sensible approach, because we just cannot get every school up to standard at the same time, but we can get there eventually.
I think it's really interesting to hear that from somebody that's just done a sizable study, that actually, like, the view is we kind of need to know where we are at a national level so we can target those spaces that need it most. One of the interesting things the study points to is that this isn't just a fact of, are there enough windows or does the mechanical system work? There's a human element to this as well. And outcomes were very heavily influenced by the human factor here, weren't they?
Absolutely, yeah. Yeah. And one of the big things we heard, and it came out of the surveys with the school teachers, was that this is a cultural issue and we need to change the ventilation culture for it to be accepted that ventilation takes priority. Because at the moment in Austria in particular, and I imagine it's the same in many, many countries, ventilation is not the priority. Human thermal comfort and human auditory comfort is the priority. And that has to change. You know, we've got to put ventilation first. It's non-negotiable in my mind in terms of priorities. It's the same as having clean drinking water. You don't question it. You don't say, oh, well, I could do without clean water for a couple of days and that's okay. You know, people would be pretty much up in arms if that happened. And it's the same.
Yeah, it's interesting you say that. It's interesting you say that. From a risk perspective, I think you're absolutely right. You know, like at the end of the day, an increasing temperature of 1.5 degrees, say, thermal comfort wise, does not present you with a toxicological or an infection risk.
Yeah.
So it, you know, in that sense, air quality comes first. But what we see time and time again from the performance studies, so the cognitive effects type studies, is thermal comfort and temperature can very heavily influence outcomes, particularly for learning, concentration, risk taking, all sorts of metrics across the cognitive effects spectrum. So I wouldn't want to say that temperature isn't important for outcomes in classrooms, but it doesn't present the same risk in the same way that being exposed to a virus or particulate matter or a VOC would do, say.
No, clearly temperature is important, and particularly the uniformity of temperatures. We often see in older classrooms, going back to your earlier point, you've got poor glazing systems, drafty, very high U values, so poor thermal insulation. And the kids that sit next to those windows in wintertime when there's no solar gain are going to be often cold. And that's just fundamentally because we're not maintaining the school building stock. We're not refurbishing these rooms, and that affects the thermal comfort of the whole classroom. And you'll have this non-uniform radiant asymmetry across the space. And that's not ideal because that means that you've then got some of the kids being cold whilst other kids are too warm. And this came out from our surveys quite a lot. There was kids actually shouting at other kids and saying, well, just put the jumper on or put your jacket on. And they were saying, no, I don't want to do that. You know, swap places, blah, 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 trying to work this out. And it became really hard for the teachers there was different strategies. Some teachers just said, I make the decision here. This is my classroom. If I say we open the window, we open the window. And others gave in and went with the kids. I'm not saying either's right. Actually, we need to create environments that are thermally comfortable because everyone has to work in that space. And we also need to realize that in parallel with that, we've got to ventilate. And that's challenging. Yeah. That's really challenging. And I think some of the older classrooms, the designers use natural ventilation better. They understood how to create a stack within the room, pull the stale air up and out from high-level opening lights. But then the rooms were often higher, you know, lower ceiling heights, single casement windows, quite difficult to do that because the windows acting as inlet and outlet. And depending on the gearing on that window, you may not even be able to control it. You know, if there's not a latch or some kind of gearing, you can often hear tilt the windows or turn them, one or the other. But if you turn them to get more air, the window's just swinging freely on the hinge. And if you happen to be the kid with a desk that's next to that window, the pane of glass could end up in your face. You might not even be able to see the board. So we're not really designing classrooms well. And I think the point here is we're always, in my opinion, going to need natural ventilation. We can't even with mechanical systems, we shouldn't be cutting off the opportunity to ventilate naturally, because that's crazy. Because resilience, if the power goes down, if there's ever a need to purge the classroom really quickly and you can't open the windows, you've got a problem. Also for overheating and so on.
So does this effectively point to a kind of a classic socio-technical challenge then for classrooms, that there's this mix of the technical engineering puzzle conundrum to fix, but also a social element to this, where it's about habits, behavior, culture, norms, that whole mix?
Yeah. I don't think people are going to change their habits unless they understand the drivers to do that. What's the motivation to do that? You need the educational aspect to accompany this if you're going to win the hearts and minds of the people who are actually in these classrooms. And I think that's really important. I can go in with all statistics and facts and figures, but you've really got to capture their understanding. And I think what we saw that was really inspiring was that we ran the study, and the government and the education department said to us, don't interfere with the classrooms. This should be largely observational. But by putting these sensors there, and in the test rooms, we also put information about how to interpret the sensor, how to ventilate your room, teachers and kids started reading this information. And that prompted a huge percentage, I'm talking more than 90% of those classrooms now have appointed a student CO2 and ventilation champion of their own volition. That wasn't my idea. That was nothing that we asked them to do. They just went ahead and did it. And in the feedback of the final survey, we heard that percentage, I think it was even possibly 96% of classrooms from our study now have a roster with a student who's appointed to keep an eye on the CO2 sensor and to inform the teacher or take action to actually get the situation under control. And
do you think there's any element of game theory here, in the sense that if schools know that the classroom next door doesn't have this, that there's did you get any feedback of the natural them and us thing that seems to happen with human nature, where you get this competitiveness for outcomes?
We wanted to kind of avoid that from a independent, observational perspective, but of course it happens, and it definitely happened, and we could see that in the feedback that the teachers where they had the CO2 sensor really wanted to see those numbers. They were at the end of the study, they're like, get this thing turned on as quickly as you can. They didn't necessarily know it was turning on the whole time, but they wanted to see those numbers on the display. And we've put them all to visible now. But there was also discussions apparently between some teachers who swapped around classrooms, who then knew the pattern to ventilate under those conditions. So they were going into another classroom with blind, with no numbers, but they knew every so-and-so many minutes they need to put that number of windows open in order to keep to the target level. So they kind of ingrained that, and other teachers watched them doing it. So this is like one of these chimpanzee experiments, and suddenly more teachers were doing this, again, who didn't have a CO2 sensor and had not been part of the study, were actually going around and learning and understood that there was some kind of pattern that had something to do with the number of people in the room and the number of windows and the time of the year, and that you had to kind of get that rhythm. And once that rhythm was established, people also reported that it became acceptable because the students were used to the frequency of this going on. And they said at the beginning, yeah, it was disruptive, but actually students settled down and they just thought, this is just something that we do. This is a culture change. We now do this.
There's a whole other study there in culture and behaviour, I'm sure. Like the cheeky side to me is wondering, because, you know, like in Ireland, for example, there was a widespread deployment of sensors during the pandemic.
Yeah.
And I know for a fact half of them are in desk drawers now or turned around and so on. And you wonder if actually there's some exploitation of that competitive thing in schools, that if you deliberately highlight the fact that some haves and some have nots, that you do get people paying attention, as opposed to it just being another, like the thermostat on the wall in the classroom. It's just another little thing with a number on it nobody cares about. You do wonder.
There's bound to be. I mean, I kind of feel like academia attracts this kind of, kind of ingrains this competitiveness in people. You know, it's all about getting points, passing exams, ticking boxes. And there is inevitably going to be an element of pride and not wanting to be a laggard. I mean, some people want to be a laggard. We also had people in surveys saying, you know, I will not open a window until the last drop of oxygen has been sucked out of this room and people are falling on the floor. I defy you to persuade me that I need one of your honky-tonk CO2 sensors, because I know what I'm doing and I'm master of this ship, you know. So
I've been doing this for 40 years. You can't come in here, young man, and tell me how to do my job. With
your clever stuff. And I thought I can respect that. And you've got these two ends of the spectrum, and maybe over time that person will, you know, I think we're just talking one or two people here out of 120, but, you know, maybe they can be won over. You know, maybe they can see that, you know, they're also tired at the end of the day. Students are lethargic. Exam results might be a little bit suboptimal. People are getting sick a bit more frequently. And they might in time be won over, you know. But I think regardless of that, what's really shocked me throughout this time, like we've gone through 5 years or more of this pandemic. It's still ongoing, but not as visible in the media. But we really haven't changed much in our culture. You know, if we talk about cultural change, we have this word in German, gemütlich, and gemütlich means like comfy or cozy or something like that. And if something is not gemütlich, then people will start complaining really quickly. And airflow and drafts and fresh air are really, paradoxically, I mean, this is a mountainous country, but having lived in the UK and elsewhere, I think people here aren't necessarily hardy in the sense that they like, in wintertime, they like to kind of snug down, be cozy. And this idea of getting a cold, sharp blast of fresh air is not in the culture. You know, it's like, why would there isn't
the Austrian equivalent of Luften, then, the kind of German airing the home, airing the building?
Not so much. There is amongst some people, and certainly you do find that in parts of Germany. But you know, it's kind of interesting, and also in the north. I mean, if you go to Norway and, you know, Scandinavia and so forth, I can remember staying in a hotel in Norway which actually had a heat recovery ventilation unit with no excess heat. So it was just recovering heat. It was probably -20 outside, and it was dumping, you know, cold air directly onto the bed the whole night. And, well, I say cold air, it was obviously not -20. It
relatively
was tempered air. And I went down to the reception in the morning and I said, I hate to complain, but I think your MVHR, you know, post heater is broken. And, they send up a chap, he had a look at it and he said, no, it's running perfectly well. And they said, you know, we like the room temperature at night to be, you know, 18 degrees, 16 degrees. We sleep better. That's in our culture. And I thought, okay, I better get used to this or get another duvet or whatever. And, you know, and from that point in time, that's some years ago, I've actually got into having the window open or cracked open all night, every night through the winter here. That doesn't change. And I really like that. I really like the cold air in the room. I think I sleep a lot better with that. So, we can change our perspectives, but there has to be some information. There has to be a driver. If you've got something that's culturally ingrained and you think, like, a common misconception that we see that came through time and time again in our surveys was that kids will get sick if they're in cold air, not they'll get sick in a stuffy, warm, overheated room without any air changes, but they'll get sick if you briefly open the window every few minutes and try to keep some ventilation going. So there is just an absolutely widespread misconception. I looked on the scientific data, and there's actually very, very few studies that can say that there's any direct correlation between being cold physically and getting sick. It's actually
so I shouldn't go out with my hair wet in cold weather because I'll get a cold.
Yeah, that's the theory.
There's no direct correlation between wet hair and susceptibility to bacteria and viruses.
Yeah. And who knows? Maybe there is but if you look at the scientific evidence for that, it's very thin. But culturally, that's a widespread belief that you need to you will get sick if you get some cold air on you for more than a few moments.
I suppose it's a difficult question to ask you, but do you get some sense from the work that you did what those kind of habits and cultures and changes we should be concentrating on to try and get a better outcome? Is there some myth busting that needs to be done? Do we need promotional campaigns? Like, what's your perspective on or engaging with the youth? Do you like these green schools schemes, that kind of thing? What moves the needle here, do you think, culturally?
I think what's really shocked me and what I think's lacking here is engagement from the Department of Education, from the Department of Health, and talking about public buildings, public transport, public spaces, and trying to shift that culture. Years ago, I lived in Australia. I grew up in New Zealand, and there was a lot of road safety campaigns that were put out there about drink driving, about not wearing seatbelts, about going too fast in towns and things like that, which were really graphic. They were really in-your-face images. But the net upshot of that was a huge reduction. Those adverts were effective. The public health campaigning or public safety campaigning had impact, and it made change. And it was backed up, of course, by law enforcement and all the rest of it. But this was a matter of reducing fatality rates on Australian and New Zealand roads that were very, very high. And it had impact, and the results stood up. But we haven't done that with ventilation. We've completely failed to give any advice to the schools. And if the head teacher doesn't know, and the classroom teachers don't know, and the facility manager doesn't know how to ventilate the room, or that it's even important to ventilate the room, they're probably not going to do it, because their cultural belief is we need to be cozy, and if we get cold, we catch cold. And that can only change, I think, with some kind of public health campaign and empowerment. We need to give them the information. We need to give them a CO2 monitor so they can look at a target, and we can all agree on a number, and we can put lights on it to make it easy for people to remember, and then we can start to change things. And I think kids will change quickly. The students are learning. They're at a formative age. And I think that's not the problem. The problem is changing the old guard. It's changing people our age and older, and making them aware that those myths, those fairy tales were not actually true, and ventilation is really important. And having an overheated room is actually detrimental. You look at the studies from Vorkogi and co, and you look at temperatures above 20 degrees, and you're seeing a decline in academic performance. just on temperature
Yeah.
alone. And yeah,
But it's complex, isn't it? You know, I think your study very clearly points out, and it's no surprise if you can see the air, if you've got sensors that tell you when a space is underperforming, if you engage with it, and there is the mechanisms to affect an outcome, you can get, and there's clearly better results in rooms that have CO2 sensors because people are aware of the air. But there is this underlying element, isn't there, that some spaces, even with awareness, aren't necessarily going to be able to ventilate effectively across the broad spectrum of the year, because the infrastructure just purely isn't there to deliver that.
Absolutely,
You know, and I think that's the concern. I think of a lot of departments of health is that they recognise they've got a very old stock profile that's been run to failure largely. That's the mode of operation for most schools. Is a kind of a, until it's hanging off the hinges, we don't fix it. Or dripping on a student, or smelling because it's getting hot, or whatever, right? So I think there's this fear, and I think they're right to be fairly frightened. There's a massive reinvestment in the education infrastructure required across most global countries. Like I think that's the bottom line. There's no escaping it. Like if there is a requirement for investment here, and that's why I think unless people are screaming and shouting about it, ultimately they don't want to know. They really don't.
I mean, being cynical, a lot of schools look like a kind of childcare facility that's run at the lowest possible cost in order to free the parents, to free the adults up, the guardians up, to go and do useful work in society. And it's only when you look at studies like we've seen Mendel et al. And so on from the States, where they've looked at cost benefit of ventilation, looked at the economic arguments, and seen that in the US model at least, the costs, the benefits completely don't add up. So the benefits are huge, the costs relatively small if you actually put all the costs in the model. So but then, you've got to do that for every country, because you can't necessarily extrapolate those findings to all other countries, because some of the funding models that were used there were based on student days at desk or student attendance. And if that is penalized financially and you're not getting as much grant money because your student attendance is lower, and that goes into your funding model, then that affects the outcome of the cost-benefit analysis. But most cost-benefit analysis that's been done has shown real success, that you can invest in ventilation and the benefits, societal benefits, are huge in terms of lost absenteeism, in terms of not having parents and guardians off work attending to a sick child, and having higher attendance in the school itself, and therefore better academic attainment overall. But it's who's paying for this? Who pays for those lost days? The employer might end up paying for one of the parents to be with a child, somewhere else, and that's just kind of absorbed into the system, and they just assume there's going to be so and so number of days lost. And if we reduce that by 3 or 4 days a year, it's maybe not that immediately visible, but the cost to society is still there. And I think that some of these big questions, it's a little bit like climate change. You need to look at the fact the people causing the problem, let's say, are not necessarily the ones picking up the bill for the problem. And I think that we've kind of got to look at this more globally if we're going to find a solution to this.
There's no bad actors involved here. There's no big oil in schools and big tobacco, and like there's no dark shadows in the corner here. I mean, this is just purely a a lack of investment by governments in something that's important to society. So it's not, there isn't an oil lobby trying to slow down the deployment of electric cars or something nefarious going on. This is pretty basic black and white maths, isn't it? It's just that we haven't valued the education system highly enough. Most schools, my schools, looking for parents to help fund flipping pencils and bits of paper, never mind infrastructure in the schools. Like, that's where it's at in a lot of cases. So it's simpler in some ways. It's a little bit more basic maths than a lot of these big questions to answer. But I think it's fair to say a strong conclusion from your report is that the responsibility for fixing this isn't at the school's feet.
No, absolutely not.
This is a national endeavor at some level.
If you look at the data for funding of education across Europe, and so how much the government invests per student, there's a massive disparity across the European Union, and that data is in the public domain. You can see that quite easily. And what you'll see is that a lot of countries where that funding is heavily reduced, the infrastructure is worse. The schools are in a worse condition. The occupant density is higher. And these are hugely influential factors. If we start cranking more and more kids into ever smaller classrooms, then this equation gets really impossible to work with. We saw that quite clearly in our data because we had a couple of special schools that are for kids with learning difficulties and so on, and they have a lot more space allocation. They were naturally ventilated schools, and both of them performed in our top 10 schools, so outperformed some mechanically ventilated schools using high-level window openings, low-level window openings, and much reduced spatial density. So spatial density, how many kids are in that room? This has a critical outcome on all of this,
I was going to say that it's just maths. It's ultimately at some point. We've had this. I don't know if Austria struggles with the temporary classroom buildings that we see across the UK and Ireland. The hard reality of those spaces, when you've got a 6 by 4 meter, 1.2 meter ceiling space with 32 kids, a teacher and 2 support teachers, like the actual air change rates you'd need to achieve in that tiny little space are just impossible. You don't stand a chance. If you've got a special class that perhaps has a much lower density, all of a sudden you're like going, well, this space is actually operating really well. So maybe beyond the infrastructure, one of the fundamental questions is density.
Yeah, it's a critical factor in this whole equation. And, we've definitely got evidence to support that these special schools on average had about 3 square meters per child. A typical value in Austria is around 2 or just over 2. In the UK, you're some way below that, and quite a lot below that in some cases. And that's just a massive factor in this. And in the best case, one of the schools had like 6.5 square meters per child. Swimming in space. But of course, if you look at an office, this would be unacceptable. Who's going to go and work in an office where you've got 1.7 square meters, of space for yourself, and then you're cheek and jowl with your colleagues? You'd be in some kind of really jammed in call center. Certainly not a typical working environment. And yet we're quite happy to do that with children. We're sort of cranking them into cages at a density that, possibly if they were, if there was an animal welfare equivalent, people might actually say, well, no, that's not enough space for a primate, I don't know. If
you create a mental image of a workplace that would replicate a classroom, you're basically sweatshop labor type environments. You're picturing people on sewing machines crammed chow by jaw, producing. That's kind of where you're at.
That's kind of where we're at
any level.
And so the next generation which the success of our entire economy is predicated on their achievements, whatever they may be, we're willing to chance all of that and certainly jeopardize that. And then what? We wonder why results aren't that great, why attendance is falling, why more and more kids are getting sick. The problems are just going to ramp up unless we turn this around. We've had the wake-up call. COVID-19 was the wake-up call. I'm not sure, what's coming down the pipeline, but we know we're going to see more of these episodes. We're going to see more pandemics, and we need to get to grips with this, really quickly.
So, Rob, if I was a country looking at your skill set and what you've done there in Austria, and I said, look, Rob, I want to bring you in as education infrastructure czar, and I want you to pull together a roadmap for me. What would the roadmap look like for a country? Like, what's the process? I'm guessing it starts with something like your report, work out where you are at your infrastructure. So figure out where you're starting from. But what are the stepping stones then beyond that? How do you start to fix this from what you've seen in the data from your report?
So fixing this, I think ultimately, if we're talking about the occupant densities that we've got currently, we're talking about the knowledge we have now about ventilation flow rates, ventilation effectiveness. In most middle, central European, northern European countries, that implies mechanical ventilation for all new schools. So if you're not doing that, you're going to have to start doing that, because you're not going to pull up on these targets, and you're not going to get anywhere near to the health-based targets, the sort of 800 ppm values that are going to be advocated. And you probably, from what we've seen, will not maintain 1,000 ppm year-round. You won't do it. So assuming those values are correct, and we've got no reason really to doubt them, both from the performance and from the health side, then you're going to have to put mechanical ventilation into new schools. And then you need to think about that as a problem itself, because that's quite easy to say that. And in a new school, that is relatively doable. But in an existing school, then you're talking about retrofitting systems, and that's a little bit more complicated, but it's also doable. And then you're going to get down into the detail of that. And I could get really into the detail of that, but I don't want to go there just yet. So the first thing you need to do is triage, like we were talking before. You need to identify which are your worst affected schools. And if you look at standards in the US, when we say identify the worst affected school, that's not just the indoor air quality, that's not just the CO2, it's also the outdoor air quality. And one of the things we did in our study was we pulled in data from the Austrian Federal Environment Agency, the UBA, from the nearest officially controlled measuring stations in close proximity to the schools. And we looked at the background air quality in the vicinity of every school. And that's shocking, because if you compare to the current WHO standards that were issued in 2021, so the revised standards that everyone should be working to, what you saw was actually failure to meet those standards. Again, for PM2.5, in every case, the background PM2.5 exceeded the WHO yearly and daily guideline value. In some cases,
and what drives that in Austria? Is that kind of solid fuel burning in winter, or?
So in terms of PM2.5, a lot of this is continental background emissions. So a lot of these emissions are just the levels are now with the WHO so low that the background level of CO2 in the atmosphere, of PM2.5 in the atmosphere, is such that it's quite hard unless you're up against the Atlantic, the western seaboard of Ireland, Norway, pretty good, northern part of Sweden, pretty good values, Finland, likewise, and so on. But as you get into the continental landmass, and as you get just off that seaboard, also in the UK, because of industry, because of fossil fuel burning, because of transport, even because of agriculture, you're getting a lot of particulates in the air, and a lot of these fine particulates can travel hundreds of kilometers and circulate and become part of the background air mass. So, then you've got another issue that you need to think about right away. If you are going to put ventilation in the school, where are the places with the worst outdoor air quality? And look at those. And you don't even need to measure anything. You can see that now we've got high resolution data, networks, federal environment agencies. We've got the same thing in the UK. We're pretty good on that front. Next thing, I would go down to the school level. And if I had a red flag at a regional or a local level, I'd go and measure the air quality on site and check it under different wind regimes and so on. A lot of gaseous emissions are part of that problem as well. Nitrogen dioxide, other oxides of nitrogen, ozone. A lot of these levels are also off the limit. Most of our schools in Austria exceed the WHO ozone values. That's the yearly average value, the daily average, and the peak season value. So there's 3 values that have to be measured there. In 100% of cases, those values are exceeded. So then you've got to look at which are the worst cases, okay? So if everyone's affected, you've then got to triage that. We saw, let's go back to PM 2.5, we saw some schools where the PM 2.5 background value was 3 times above the mean, okay? So their mean value is 3 times the WHO threshold. So that would go straight on my red flag list. That school needs filtration, because without filtration, talking fine particulate filtration, you've still got an issue.
Yeah, more outside air isn't necessarily the answer in every case, is it?
Absolutely.
That's the reality.
Yeah, it's absolutely not. I mean, there was a study done by Greenpeace in Belgium that was published in 2018, and they were monitoring NO2, gaseous emissions from transport, and they were looking at schools that were close to main carriageways, arterial road systems. And again, they were way above the WHO levels in most of those schools. And they actually found, paradoxically, that classrooms that had the windows shut had lower levels of NO2 inside the classroom than those who were ventilating for CO2 and actually having better ventilation rates. And that absolutely illustrates that problem, that you can be pulling one value down and putting another value up because you're replacing stale classroom air with outside air that's way above WHO guidelines. In the US, in the planning phase, if you were working in accordance with ASHRAE 62.1, if you look at Appendix AA to that document, it says that every study of a ventilation system in a school requires a regional analysis and a local site-specific analysis for a quite long list of pollutants that are documented in that standard. We're not doing that in Europe. We need to be doing that, because otherwise we're putting ventilation systems in and we're just pumping through pollutants if we're not taking them out. Now, we have to be realistic about that because we cannot filter everything, but particulates, relatively low-hanging fruit. And I think we need to be getting to a place where we're using data more smartly. We need to be filtering on the days we need to filter. That might be every day in some cases, but it might only be a few days in others. So we need system manufacturers, developers of ventilation systems to start getting smart with their equipment so that we're only filtering when we need to. And that's important because that affects the energy use, the running of the machines, the pressure drops across units, and the duty that device is working under. And we can filter intelligently. We can do that just with a damper, sending the airflow through the filter or not through the filter.
So this isn't about you in this roadmap saying, look, we need 5 trillion to fix this problem or something. It's about saying, look, we've got the knowledge, we've got the engineering solutions, we can collect the data. This is about us understanding where we are today and strategically triaging with data and knowledge the low-hanging fruit here, that there's an opportunity to fix this with engineering solutions with the right focus.
Yeah, we're already doing it in an ad hoc way around the world. So the Americans are doing one thing, we're doing another thing. We need to bring together best practice, and that document needs to be in one place, and it needs to be made available to education departments and anyone working in the development of schools or the refurbishment of schools. And there needs to be a meta document, a meta roadmap, like we were talking about, where we triage that country and we know which schools we're going to target. And in the meantime, almost every naturally ventilated school would benefit from having a CO2 sensor.
Yeah.
During winter, they probably will benefit from having a Corsi-Rosenthal fan box filter or 2 or 3 as well. And we need to get with that and start triaging and making sure the worst affected schools have that stuff. But the basic information needs to go out to everyone.
And what's the population of Austria? How big is it as a country?
I think it's actually quite small. I don't know. I'm not sure if we're at 9 million, I'd be guessing.
I don't know. We won't Google it here, but your sense of it is, like, from a time frame perspective, for a country the size of Austria, say, because you could extrapolate that out, that might be the size of a state in one of the states in the US or Ireland or something comparative. It took you a couple of years to do a report and get a baseline with the right investment. Who funded the report, by the way? Where did that, was that like a national?
The government paid for the report. So the Minister of Education, Science and Research authorized the study. And so they paid for the work. Yeah.
So a couple of years and some funding can get you a good baseline as to where you are, roughly. The kind of thing that you're talking about, that kind of national rollout of measurements and triaging and so on, like it's not unrealistic, I would guess, to say in a 5-year time frame you could come out the other side in 5 years with a very good plan at the very least, and have started to action the higher risk schools as part of that process.
Yeah, absolutely. And I think, we need the data to do that. We need to get some measurements in these places, but a lot of that data is already there. So all that background data, the outdoor data, pollutant data, that's all there. We're not doing anything with it, but it's there. We're not doing anything. We're not acting on it in the sense that we're talking about. And the indoor data, we could also crowdsource that. We could get sensors out if we had enough sensors out. If kids were wearing, wearable sensors or whatever, we could get that data a lot quicker. There's platforms now, I'm sure you're aware of in many different countries, the Raven system and so on, where the Boston schools are getting data in kind of voluntarily. That's also happening in Germany. There's a platform where people are taking devices into schools, buildings, wherever they go, and data's streaming out from those places. And we're starting to get a picture. We're getting a profile of certain chains of hardware stores in Germany, how they're comparing to their competitors, how the local takeaway joint's doing and so on. And if you get enough data together, you start to create a picture, So it is kind of happening organically, but we're not resourcing it. If we want to do it in the way we've done it, in a structured way, then let's get on and do that. But the worst thing we can do is just ignore all the data that we've got.
Yes. Yeah. And there's an agency thing here, and that is, our kids don't have the agency here. Children in schools do not get to control those spaces, invest in those spaces, decide who runs those spaces. That's on us.
Yeah.
And it's, I think that's a very powerful frame to see this from. We are obligated to look after the next generation that are coming through that system.
Yeah.
And with the knowledge that we have now, and with reports like yours, which I'm going to share on the podcast show notes, and it's widely available. Don't get me wrong, it's a hefty document to read, but there is a summary document as well, which provides some really good overall coverage of it. Yeah. It's not like we don't know, like we can't realistically turn around and say we had no idea the state of the art. it's clear in black and white in those pages that this is where we are. These are some of the complexities and the nuance and the solutions.
Yeah.
But we can't say we don't know.
Yeah, no, we can't say that. And we've been absolutely clear in our conclusions and our recommendations that we're not pulling our punches here. We need to take action. It has to happen at the federal level. It has to happen not at the individual school level. It needs to take place in a coordinated way. Because if it doesn't, we're going to perpetuate the inequalities that we're seeing in the data now. There's terrible inequalities. The inequalities exist, in the background, in the backdrop anyway, but we don't need to exacerbate those by not taking control of the situation. But what we need is more adults in the room. We need people to step up to the plate and say, it's time for change. We need to close that chapter and move forward.
Yeah, I can't remember. I think it might have been Adam Taylor made the point, and I thought it was very profound, that we can't fix a lot of the inequalities in society through the schools. But what we can recognise is that a school can be one of the few places where that inequality doesn't have to exist for a child. It can be their only warm place they go to that week. It can be the only place they go to where they get a square meal or food or safety or good air quality.
Yeah.
And that's on us. Like, we have that, but we can't fix every child's home environment. We can try.
Yeah.
But what we can do is create a space that they spend a large amount of their formative years in, creating the best possible foundation for their long-term health and well-being.
Yeah, absolutely agree. Those are the formative years, and what we provide then is really a reflection of ourselves as a society and our aspirations and hopes for the future, for the next generation. If we don't care, then we show that by neglect. We show that by doing nothing and leaving things as they are. But if we care about those people and want them to achieve their best, then we need to create that environment. And as you say, it needs to be a level playing field. If it's the only sense of community, it's the only thing that they have that's of quality, of a standard that we can take care of as a society, then we are obligated to do it, in my mind.
Rob, it's been absolutely fascinating talking to you. It's been a really interesting report to read and get into the detail of. I can't say I've read it completely in detail. It's one of those ones I think you'll go back, because there's elements and sections of it that will be relevant to something particular that you're looking at, because it really is quite broad and deep as a report. So absolute congratulations to you and your team and all the technical people and all of the schools and people involved in it, and for the Austrian government to be brave enough to commission this report and have a good look at the state of schools. I think everybody involved in this is to be congratulated. It really is a fantastic piece of work. Well done.
Thank you very much, Simon. It's been a real pleasure to come on to Air Quality Matters and to talk about these things, especially with yourself, someone who's very knowledgeable and has listened to many different perspectives, because it is a complicated landscape. There's a lot of nuance here that needs to be disentangled, but I think there's some fairly clear themes. It's the solutions to this, I don't think are overly complex. I think as a society, this is something we can very easily respond to, and we just need to commit to that path. But thank you.
Well, Rob, on that note, thanks a million. I really appreciate your time. I'll speak to you soon. Take care. Thanks for listening. Hold on a minute. Before you go and shoot off or onto the next podcast, can I just grab your attention for 1 minute? If you enjoyed this episode and know someone else you think might be interested in this subject, or you think should hear the conversation, please do share it, and let's keep building this amazing community. And this podcast would not be possible without the sponsors: Aico, Aereco, Ultra Protect, InBiot, 21 Degrees, Farmwood, and Eurovent. They're not here by accident. They care deeply about the subject too, and your support of them helps them support this show and keep it on the road. Please do check them out in the links and at airqualitymatters.net. Also, check out the show on YouTube with video versions of the podcast and more. See you next week.